Now let's look at the classification of the materials. So broadly, we are talking about liquid mixing, solid mixing, and high viscosity mixing. Mixing in liquids takes place due to the flow currents. So when you talk about flow currents, they could be axial and radial flow. Let's just look at what we mean by axial flow and radial flow. The image onto the left will show you radial flow. The one on the right is basically an axial flow. In axial flow, there is top-down mixing, whereas in radial flow, the mixing happens across the periphery or along the diameter of the impeller. There could be applications which demand axial flow. There could be applications which require radial flow. So depending on the application, we could choose the kind of mixing impeller. Now let's look at mixing in solids. So solid mixing is very different from liquid mixing because there are no flow currents in the case of solid mixing. And when you take what you say is a well-mixed sample in solids could differ in composition at certain places. So here's a look at how solid blending actually takes place. This is a V blender in which you can see here different materials. There are hardly any flow currents. The principle of mixing here is diffusion blending, which is small scale random motion of particles caused by the rotation of the mixing vessel. Besides diffusion blending, the other mechanisms are convective blending, where there is large scale movement of particles due to the action of the agitator, and shear blending, where impellers and special kinds of mixing blades are used to cause shear to facilitate the mixing process. We'll now look at mixing of viscous materials and doves. Again, this is extremely different. So the principle of mixing here is, or the mechanisms of mixing are distributive mixing and dispersive mixing. In the case of distributive mixing, I'm sorry, that's not the right video. You just pause for a second and get back to. Yeah, this is mixing of fondant in a sigma mixer. So again, very different from how you would have in the case of liquids and solids. Here there is kneading, there is dispersion, there is shear, and it is a combination of distributive mixing and dispersive mixing, which actually causes the material to mix. So mixing can only be achieved in such equipment by force shear or by elongation of matrix. There is a need to ensure that there is lateral and transverse motion of material.